Okay, the second chunk of concept review, 7 through 12. So 6 was pretty challenging, a lot of pieces to it. 7 is just a more abstract problem saying take x and raise it to the 1/3 power. Well, that's x, and then the numerator of my fraction tells me to raise my base to that power, and the denominator tells me that's the root that I'm doing. I'm doing the cube root of my base to the first power. I can't simplify that any further other than it's the cube root of x. And that's as simple as I can make it, okay? Now moving on. 8, okay? This notation is very important. It is the whole, oops, let me do it in red. The whole quantity raised to the 1/2 power. So the powers are going to get distributed to each term. So this is, and remember, 1/2 power is just simply square root. All right, my bad. Zooming out. Okay. There we go. So this is really, right, this is really a product of the square root of 4 and the square root of g. Okay, because that's that 1/2 getting distributed to the 4 and the g. All right, well, the square root of 4 is 2. And I can't do square root of g, so it's just 2 radical g, and that's it. All right, and I was applying it to both because the parentheses, tell me everything inside there is getting raised to this 1/2 power. Those parentheses are important. 9, on the other hand, is a very typical SAT problem. Do you see any parentheses? Does this say the whole thing raised to the negative second? No, it doesn't. Okay, notice, look at this and compare it to the previous problem, had those parentheses. That changes things, right? This is really the number 4 raised to the first power, just 4. And then it's the x raised to the negative second power. So this is 4 times x raised to the negative second power. Well, raised to a negative tells me do the reciprocal. So instead of x, it's 1/x squared. So simplifying this, it's numerator times numerator. It's 4 times 1, 4, and 1 times x squared. It's really 4/x squared. So parentheses matter. Here, only one thing is getting raised to the negative second power. All right, that 4 is not touched by it. Now, in 10, see, it's the same problem, except now we're using a y, and there's parentheses. These parentheses change it all right? It's this entire, whatever's in the parentheses is getting to get raised to the negative second power, all right? So 4 raised to the negative second means it's 1/4 to the second. And that y raised to the negative second is 1/y to the second. Well, 4 squared is 16, so that's 1/16, and I can't simplify y squared, so it's 1/y squared. It's a product, so we just multiply 1 in the numerator, and it's 16y squared in the denominator. So here's the comparison. When it's the whole quantity raised to the negative second, it's the entire thing in the denominator. The entire thing's getting raised to that negative second power. Whereas when only one term is getting raised to that negative second power, there's the change. That 4 stays intact. That 4 stays, because it wasn't affected. It wasn't touched by that power. 11. Kind of tricky, but definitely not as bad as 12. So let's handle it. First check, is it a negative power? No, it's not a negative power. So it's just this whole entire thing, right? There's the parentheses. It's that 9m. And then the numerator is telling me take that entire thing and cube it. And then my denominator is telling me, well, square root it. Okay? Always handle what's under the radical and what's in the parentheses first. Okay? So this equals the square root. You can drop that square if you want. And then it's the 3's getting distributed to each term. So 3 cubed, it's, oh, you know what? I could square root first and then cube. Instead of cubing, I can square root. What's the square root of 9? All right, let's do that. Let's do it that way. Let's do the whole entire thing raised to the power. Let's evaluate the square root first. Multiplication doesn't matter the order, so associative, I think, is what it is. Darn. So the square root of 9 is 3, and then the square root of m is, well, radical m. There's square root of m. Now let's go ahead and cube it, because that'll be way easier. Rather than making it big with the cube and then square rooting, I'm going to make it small and then make it bigger, right? So let's distribute this, right? 3 cubed is really 3 times itself 3 times. That's 9 times 3. That's 27. So 3 cubed is really this 27. And then radical m cubed is radical m times itself 3 times. Well, a radical times a radical makes it drop. So you're going to get m here. M radical m is what's left over. So radical m cubed is really this thing here. It's really m radical m. All right, so this problem, 9m raised to the 3/2 power, you get this, okay? And this trick here, what I did here, instead of cubing and then square rooting, I noticed 9 was a perfect square. So I said, let me do the square root first. You have that flexibility in these problems. You can do the square root first, or this squaring thing, whichever makes it easier, okay? All right, and then last but certainly not least, this beast of a problem for number 12. This is a tricky problem, and I'm going to rewrite it, okay? I'm going to rewrite my numerator. It's 27b raised to the 1/3 power all over 9b, all of that, right? There's those parentheses, right? Parentheses, raised to the negative 1/2 power. Okay. So, when in doubt, take it slow. I'm going to deal with this negative first. So let's keep that 27b raised to the 1/3. Okay. And then this negative is telling me do the reciprocal. It's really 1 over 9b to the 1/2 power. Well, I've got a fraction with a fraction of the denominator. So that's keep my numerator, keep the 27b raised to the 1/3. Right? I'm keeping those parentheses. Change the operation, right? No longer division, now it's multiplication. And then it's flip this fraction, do the reciprocal. So it's no longer 1 over the square root of 9b. It's now the reciprocal of that. It's just 9b to the 1/2 power, okay? Well, we started this lesson with a rule that when you have and this is why I started with a review of what happens when we multiply like bases. Okay, what happens with these powers? These are like bases. They are. Okay. If these, what you're supposed to do is when you have like bases, you keep the base b, you multiply their coefficients, and then you add their exponents. Okay, so let's do that. It's keep the base b, because this is a monster of a problem if you don't know these shortcuts. And then it's 9 times 27. Hell, I don't know how to do that. I really don't. But I'll tell you what. I can, let me do the square root. All right, you can do it another way. If you really wanted to, this problem is the same as 27 times 9 to same as, oh man, 243b, all raised to the 1/3 plus 1/2 power. Okay, I'm going to come at it a different way. I'm going to notice that this is a square root, and it's the whole entire thing getting square rooted. So what's the square root of 9? Well, that's 3. Let me put that over here. 3. And then what's the square root of b? I don't know. That's radical b. Okay, and we're still multiplying. And then here, what's the cube root of 27? I think the cube root of 27 is 3. Right? 3 cubed is 3 times itself, 3 times. All right, that's 9, and then times 3. Yeah, that's 27. So the cube root, what number times itself gives me 27? Oh, that's 3. Okay, and then it's the cube root of b. All right, I'm going to leave this as 1/2, and I'm going to leave this as 1/3. Now we come back to this idea. Now it's much easier. Now I can do it, because that 27, it wasn't 27 times 9. I couldn't do that. I had to deal with these exponents first. So I distributed it. What's the cube root of 27? That's 3. What's the square root of 9? Well, that's 3. Well, I didn't just get rid of it. I then applied it to the b, right? And that's where I have this b to the 1/3, and I applied it to the other b, and that's where I have b to the 1/2. So now I can do my like base rule, right? Multiply the coefficients, 9, keep our base b, and then we add our exponents. There we go, add our exponents. I knew I was doing something wrong. Now I got it. So this is really 1/3 plus 1/2. Okay. Well, we can't add 1/3 and 1/2. They have to have a like base. So 1/3. You're looking for a common multiple. 1/3 is the same as, let's double both numerator and denominator to preserve equality. 2/6. And 1/2 is, well, right, if I multiply this by 3/3, right, that's the same as multiplying by 1. I haven't changed its value. Well, that's going to give me 6, and 3 times 1 is going to give me 3. So this is really 9b raised to the 1/3. Instead of 1/3, I'm going to put 2/6. And instead of 1/2, I'm going to put 3/6. All right. This is really my base, 9b, raised to the 2/6 plus 3/6 power, all raised to the 5/6 power. And the b is what's getting raised to the 5/6, not the 9, right? Because we dealt with its exponent over here. So it's 9 times b raised to the 5/6. All right, that should be your final answer. Yes, I know that last one was a monster, but you kind of just gotta practice these.